All right, and picking up where we left off, this is part 2 of chapter 6, learning. How do we learn predictive associations? We learn predictive associations through conditioning, the process that connects environmental stimuli to behavior. Psychologists study two types of associative learning, classical and operant conditioning. Classical conditioning is learning that a stimulus predicts another stimulus. And operant conditioning is learning that a behavior leads to a certain outcome. Behavioral responses are conditioned. Watson was influenced by Ivan Pavlov's research on the salivary reflex. This is an automatic response when a food stimulus is presented to a hungry animal. Pavlov won a Nobel Prize in 1904 for his research on the digestive system. Pavlov noticed the dogs salivated as soon as they saw the bowls that usually contained food, suggesting a learned response. Here's an image of Pavlov's apparatus and classical conditioning. Ivan Pavlov, pictured here with his colleagues and one of his canine subjects, conducted groundbreaking work on classical conditioning. In the lower part of the pictures is Pavlov's apparatus. He used this to collect and measure the dog's saliva. Classical Pavlovian conditioning is when a neutral object comes to elicit a response when it is associated with a stimulus that already produces that response. A typical Pavlovian experiment involves conditioning trials, neutral stimulus, and unconditioned stimulus. Conditioning trials are when a neutral stimulus and an unconditioned stimulus are paired to produce a reflex, for example, salivation. A neutral stimulus is anything the animal can see or hear as long as it is not associated with the reflex being tested, for example, a ringing bell. An unconditioned stimulus is a stimulus that elicits a response, such as a reflex, without any prior learning, such as food. Classical Pavlovian conditioning also involves test trials. The neutral stimulus alone is tested, and the effect on the reflex is measured. Pavlov used the metronome sound to measure the salivary reflex. All right, this leads us to the unconditioned response and unconditioned stimulus. The unconditioned response is a response that does not have to be learned, such as a reflex. In the case of the Pavlovian experiment, it would be the salivation as a response to the food. The unconditioned stimulus is a stimulus that elicits a response, such as a reflex, without any prior learning. This would be the food itself. In this case, the unconditioned stimulus, the food, elicited the unconditioned response of salivation. Then there is the conditioned stimulus and the conditioned response. The conditioned stimulus is a stimulus that elicits a response only after learning has taken place. In this case, the clicking of the metronome is the conditioned stimulus because it had been paired with the food. The conditioned response is a response to a conditioned stimulus, a response that has been learned. In this case, it would be salivating in response to only the metronome. Here's a graphic from the book that lays out the experiment. You see the food elicits the salivation. Then you pair the food with the metronome. Then you present only the metronome and the dog salivates over the metronome. Learning is acquired and persists until extinction. Pavlov was influenced by Charles Darwin and believed that conditioning is the basis of adaptive behaviors. Acquisition is the gradual formation of an association between the conditioned and unconditioned stimuli. This is the process of associating the metronome with the food. The critical element in the acquisition of a learned association is time or contiguity. The less time between the conditioned stimulus and the unconditioned stimulus, the metronome and the food, is key. If you'll notice when watching scary movies, they will play scary music just before a scene to get you ready for that scene. Here's another graphic from a book laying out this experiment. The acquisition, extinction, and spontaneous recovery. Acquisition was the pairing of the food with the metronome. It extinguishes if the metronome is presented alone after time, and it can cause a spontaneous recovery if presented alone later. It eventually extinguishes over time when presented alone. Second order conditioning. A conditioned stimulus becomes associated with other stimuli associated with the unconditioned stimulus. Second order conditioning helps account for the complexity of learned associations, especially in people. In another Pavlov experiment, a black square was presented with the metronome without food, when the metronome was being paired with food at other instances. Later, the black square alone produced the salivation. All right, generalization and discrimination of the stimulus. Stimulus generalization is learning that occurs when stimuli that are similar but not identical to the conditioned stimulus produce the conditioned response. This would be like having some sound that's similar to the metronome also producing the salivation. Then there's stimulus discrimination. This is a differentiation between two similar stimuli when only one of them is consistently associated with the unconditioned stimulus. For example, plants look similar, but we learn how to avoid poison ivy. And on to extinction. Extinction inhibits the associative bond, but does not eliminate it. Animals must learn when associations are no longer adaptive. Extinction is a process in which the conditioned response is weakened when the conditioned stimulus is repeated without the unconditioned stimulus. In this case of the Pavlovian experiment, it would be the presentation of just the metronome without the food. It eventually loses its effect. All right, we mentioned spontaneous recovery earlier with that graphic. This is a process by which a previously extinguished conditioned response reemerges after the presentation of the conditioned stimulus. This would be if you've provided the metronome and they've gotten over the metronome without the food, but then later the metronome surprisingly makes them salivate later. That is spontaneous recovery. And this recovery will fade unless the conditioned stimulus is again paired with the unconditioned stimulus. Learning is based on evolutionary significance. Pavlov's original explanation for classical conditioning was that any two events presented in contiguity would produce a learned association. Pavlov and his followers believed that the association strength was determined by factors such as the intensity of the conditioned and unconditioned stimulus, a louder metronome, or a larger amount of food. However, in the mid-60s, A number of challenges to Pavlov's theory suggested that some conditioned stimuli were more likely than others to produce learning. In other words, contiguity was not sufficient to create conditioned stimulus and unconditioned stimulus associations. Conditioned taste aversions. It's probably going to hit home for some of you. Psychologist John Garcia and colleagues showed that certain pairings of stimuli are more likely to become associated than others. In conditioned taste aversion, the association between eating a food and getting sick is at play. A response occurs even if the illness was caused by a virus or some other condition. This is especially likely to occur if the food was not part of the person's usual diet. A food aversion can be formed in one trial. Animals that associate a certain flavor with illness and therefore avoid that flavor are more likely to survive and pass along their genes. Learned adaptive responses may reflect the survival value that different auditory and visual stimuli have based on potential dangers associated with the stimuli. And that concludes part 2 of chapter 6